All right, Glenda, take it away.
Thank you, Maricela, and good morning, everyone. It's my pleasure to welcome you to this year's Teaching and Learning Project Showcase, hosted by the Center for Teaching and Learning. Today, we have 10 excellent presentations for you to choose from in a conference-style format. In each presentation, instructors will share some of the things they've learned when they designed and tried out and assessed new ways of teaching in their own undergraduate classes. To introduce the showcase, I'm so glad we have with us Interim Vice Provost for Undergraduate Education, Oliver O'Reilly. He's our intrepid leader of the undergraduate division, a distinguished teacher in his own right, and a longtime friend and colleague to many in this Zoom room. So a warm welcome to you, Oliver.
Thank you so much, Glenda, and thank you for having me here today. Before I start, I just wanted to thank Maricela for running the show, and just to thank you all for everything you're doing for our students right now. I know this has been a very challenging semester and an academic year, and I know that every act of kindness that you show our students, they appreciate it. They may not say it, but I know it's appreciated just from talking to students over the last few weeks and months. Today, I'm really honored to be here to introduce the presentations for the Presidential Chairs Fellows Program. This program funds faculty teams to carry out undergraduate curriculum redesign efforts at the program level. And for this cycle, the fellows have developed projects to address opportunities for fostering equity, inclusion, and community. Many of our students, the one thing that I really noticed when we all came back in the fall semester was this incredible yearning for community and belonging. I don't know if you remember just seeing the number of students out on the glade, the number of students walking around campus, talking to each other, was just extraordinary. I'd never seen a start to a semester like that. And you could just tell that there was this desire for community, this desire for the sense of belonging. And I've seen that all throughout the semester. It's been wonderful to see again, and it's something I think we've all missed. So I applaud these efforts because some of the most critical moments in our students' time at Berkeley is in our classrooms. So anything we can do to foster community, inclusion, and equity in our classrooms is to be raised up and applauded. So thank you for that. The second program today is the Lecturer Teaching Fellows Program, which funds lecturer teams to develop dynamic tools and resources for enriching and innovating teaching and learning practices on campus. Fellows often develop and pilot projects in their courses to inform interdisciplinary and campus-wide implementation plans. And so I wanted to take this opportunity to thank all the lecturers on this call for all their amazing work. I had the privilege of being at the Distinguished Teaching Awards, where one of your colleagues, Pablo Gonzalez, received the Distinguished Teaching Award. And it was just extraordinary to see the profound influence his classes have on our students. And I know he represents one of many of the extraordinary lecturers on this campus. So thank you for all you're doing. Today's presentation are opportunities for all of you to see other groups and see everyone else's work. I'm very interested in improving the academic experience for our students, but I know we can only do that if we improve the supports we provide our students, the advising we provide our students, and the instruction we provide our students. We can't do this in a piecemeal way. We have to do it all in a collective way. So I'm very interested in these your projects this year. I won't have time to see them today because I have to jump on another call to select scholarship recipients. But I would ask you to forward me the links to your presentations because I would really like to see them and go through them. We have a lot of work to do on our campus to improve the student experience. We have a journey to go through together, and I would really like to help move us along in whatever way I can on that journey, because I think the effects of it will be profound and we can do more we are more than the sum of our parts. And part of my job is to help make that, synthesize that and make that happen. So I hope you enjoy today's presentations and hear new strategies to teach. Please share your thoughts with me. Please share your presentations with me. And mostly, I just want to say thank you for all you're doing to improve the student experience on our campus. And I wish, as I've said at the mega meeting yesterday, for all of you who are mothers, I wish you a happy Mother's Day on Sunday. And for all of the mothers of all of you, I wish them happy Mother's Day as well. And I know I'll be celebrating it with my mother by raising a glass of Guinness Clear with her. So thank you. I hope you have a wonderful, the final exams week go well. And again, thank you for all you're doing for our campus.
Thanks so much for those amazing remarks, Oliver. The next slide shows you a description of the event where we have 3 breakout rooms for you to choose from all of these amazing projects that are just wonderful, wonderful models of the transformative teaching and learning that's happening on this campus. We have designed this event as almost a choose your own adventure. So feel welcome to pop around different breakout rooms according to the presentation that speaks most to you. We invite folks to stay for the duration of the whole event, but if you do need to step away, always feel welcome to come back. You should be able to select your own breakout room throughout the 2-hour event. So with that in mind, we'll go ahead and link you to a copy of this event program so that you can have that up and ready on your screen. If you have any questions, feel welcome to enter back into the main room where CTL colleagues will be here to help support you. And we also have an unmoderated breakout room. That'll be the 4th room that is not listed here, but it's designed to be a coffee chat or a breakout room space for folks to connect. So I will go ahead and check in with my CTL colleagues to see if the breakout rooms are ready to go.
All right, great. Are we ready to go? All right, Ellen, you're gonna control the slides. Excellent. All right, well, hello everyone. Thanks for coming. My name's Diana Bautista. I'm a professor in molecular and cell biology, and I've been really fortunate to work with an amazing team, including Professor Ellen Lumpkin, PhD candidate Danielle Spitzer, and PhD candidate Madeline Arnold. Together, we're Team Biodiversity and Inclusion. And really, our goal has been to enhance large lecture-based upper division courses with active learning, participation, and low-stakes assessment. As a general introduction to our course, we've been really focused on MCB 136, a physiology gateway course to many STEM and medical career paths. Our students, there's about 200 to 300 every semester. So it's a large upper division class that serves a variety of different career paths. And in the next slide, I want to highlight that we have a very diverse student group and student body. About 21% of our students are so-called peers, persons previously or historically excluded on the basis of ethnicity or race. And we want to make sure that in these large classes, we can really cater to all of our students' needs who have very diverse learning preferences and experiences and backgrounds. And so really our goal is to ensure that all of the student body succeeds. And in STEM and the life sciences, in the next slide, this is really important because we know that these persons who are historically excluded from science persist at much lower rates than non-peers. And this is true at the bachelor's degree level. And compared, the same groups of people compared to non-life sciences persist at much higher rates. So there's something unique to the life sciences that really creates these equity gaps at the bachelor's degree and even more so at the level of the PhD degree. And we want to make sure that we have equal persistence rates for everybody across all stages of life science careers. So we know from evidence-based literature that the current STEM teaching methods perpetuate inequities and really don't adequately prepare all of our students to reach these goals. And these opportunity gaps in STEM really make it difficult for historically excluded groups to build science identity, to succeed academically, and as I mentioned, to persist in science careers. So our goal is to really think about active learning. We know from the literature that, especially in science, engineering, and math, that active learning increases classroom achievement, and especially for these historically excluded groups. And in the next slide, we really want to highlight that there's this really great potential to reduce educational inequality by making these changes. So our project has been to redesign this course and to use this as a model for other courses by adding structure, modifying assessments, and really focusing on engagement of students during class time. So before, in-class time was really focused on the instructor speaking to the students. And after these modifications, we want to increase student participation. In addition, we also want to focus, in the past, we focused on, facts that they could read in the textbook. And now we're really highlighting applying those facts to the process of science and discovery and medical advances. And in addition, we've been working to change assessment instead of these big high stakes midterms and finals to really have frequent opportunities for low stake assessment. And let's see, in the next slide, we want to say that we piloted these changes in fall 2021. We implemented active learning in 10% of lectures. And one really exciting outcome is in one activity where we used a simulator to model changes in electrical activity in neurons. On average, before active learning was implemented, about 84% of the total points in midterm questions were achieved. Whereas after our active learning, 97% of the possible points were achieved in this last new iterative version of this class, suggesting that at least in one example and one pilot, that this really shows that there's potential for changing student learning by including these assessments. Professor Ellen Lumpkin will tell us about how we redesigned our grading policies and how we assess the effectiveness of our interventions.
Rookie mistake. Thank you, Diana. So what I want to talk about is just really focus on two outcomes, and then Danielle and Madeline will tell you what we're doing now to implement our lessons learned moving forward into next semester. So for low stakes assessment, one of the things we implemented are very short quizzes called entry and exit ticket sets. So these are really short 2-minute, 1-question quizzes that cover a key concept that was introduced in pre-course materials and was covered more extensively in our in-class materials. In this model, the same quiz is given at the beginning of the class and the end of class. One advantage of this is that that students can track their learning almost in real time. So they get the answer after the exit ticket, so they can see right away, did I grasp that concept, or is this something I need to think about a little bit more? Another important outcome is this provides information to us about the effectiveness of our pre-class assignments. So in this case, again, this is one example where we analyzed before and after data for one particular lecture. The entry ticket, based after they had presumably consumed the pre-course assignment, which was a set of lecture videos, 65% of the students got the question correct. So they really grasped this key concept. So that was pretty good already. After the in-class lecture, however, in-class engagement, that percentage went up to more than 80%. So that told us that consuming and engaging in the in-class active learning did support learning gains. Now, because this was Zoom-based, and recorded, we had an opportunity to address one particular possibility of this gain. And that's just that they saw the question twice. So that's kind of trivial. But it turns out that our students had a Discord where they would tell all the other students if they got an entry exit ticket. So whether or not they came to class, a bunch of students went in and took the quiz. So we had a comparator group of students who didn't attend lecture, but took the quiz anyway. And so there are a couple of things I want to point out. First of all, the students who didn't engage in class actually probably also didn't engage in the pre-course materials because their entry ticket percent correct was already lower. Second, their exit ticket percent correct was lower than those students who engaged in the active learning. And in fact, although you see an increase in percentage correct, that increase is not statistically significant. So we're very excited about this initial analysis because it shows us that engaging in the active learning activities will allow students to gain knowledge in real time. We also then, well, one thing we noted is that these frequent low stakes assessments and in fact just deadlines in general was very stressful and anxiety producing to our students. So we took the opportunity to do a mid-course survey to get feedback from the students during the course about how we could lower anxiety for assessments and what type of assignments they really felt allowed them to best assess their learning. And what you can see from this word cloud, so this was a fill box so they could tell us whatever they wanted. And then we ran a word cloud analysis. And what you can see is that overall, the types of assessments we used, they really appreciated. So short quizzes, very frequent, lots of practice exams where it doesn't matter if they get the question right, but they have an opportunity to practice. The other thing that really came up is that they wanted the feedback, they wanted the answer keys, and they wanted it in a timely manner. So the lessons learned from our pilot are that active learning exercises should focus on the scientific process rather than memorization. I didn't show you the data to support that. Students should work through problems together in class. They really craved consistent structure, which because active learning activities can vary and styles between instructors vary, students felt like they weren't anchored in the structure of our course. So they need this to engage fully in active learning and to reduce their anxiety. They want these low stake assessments, but they want rapid feedback. And finally, this use of a mid-semester instructional assessment was quite effective in allowing us to course correct during the course, and we'll be implementing that going forward. So I'll turn it over now to our GSRs to tell you how we're restructuring moving forward based on these lessons learned.
Right, so we're using some of those lessons specifically about the need for structure and the need to increase the amount of active learning to prepare more comprehensive changes for the upcoming fall. So the way we're thinking about this is really moving away from the traditional model to a flipped classroom model where there's more opportunities for active learning. So in the traditional model, the knowledge acquisition happens in the classroom where there's a lecturer and the students are passively consuming the information, and then they go home and they have to do the knowledge construction on their own. That might be through, homework or studying for exams. Whereas what we're hoping to do in this flipped model is have the knowledge acquisition happen on their own at home, where students can look at lecture videos or read textbooks, and then they can have a more interactive knowledge construction phase where they're talking to their peers, having one-on-one interaction with instructors. And this will allow more time for feedback in class about those difficult concepts or more complex skills like problem solving and data analysis that we really want to get to as we move away from a fact-based goals to more process of science goals. So we're excited about this, and I'll tell you about how we're doing that. So to focus on this knowledge acquisition phase at home, we're giving students either textbook readings or lecture videos, and we can actually use some of the lecture videos that were made during the pandemic. And then we're also providing students with guided reading questions. And the reason we're doing that is because, like Ellen said, active learning and this new flipped classroom model might not be familiar to students. So we want to make sure that we make it clear and transparent to them. What do we want you to get from this reading, and help guide their learning so they know the key concepts that we want them to understand before they go to these in-class activities. So then when it comes to our in-class activities, we're really trying to structure them around very explicit learning objectives. And as Danielle and I were working to redesign the course, we realized that it's most effective to do it in a backwards design way, where before we develop the activities, we really figure out exactly what objectives we want students to come away from at the end of class. And we're also making it very explicit to the students by having a slide. So I have an example of the slide that we might show them at the beginning of lecture, where we actually tell the students, here are all the objectives that we are hoping that you can come away from at the end of class. And then as we move through the class, we check them off as we do different activities so students can really track their learning progress. And then I'll pass it off to Danielle to talk about some activities.
Yeah, so we showed you a sample objective slide, and this is some sample activities of what it might actually look like if you were in class as a student for this lesson. So for example, we may open up with a sort of warm-up problem where we're having students check their knowledge about material covered in the pre-class readings. And this also is important because although we really hope students are coming to class prepared, we also want to do brief reviews of what happened before class so that students still come to class even if they aren't prepared and get something out of it. Again, trying to help students get the most out of in-class time. Next slide. We also are going to be providing for example, opportunities to scaffold their learning, providing templates to organize complex information to help students develop some of those metacognitive skills of making connections between material, which is sometimes easier to do from the perspective of an expert rather than a novice when you're first acquiring the information and trying to decide how things relate to each other as you're going. Additionally, we give students the opportunity to practice problems that are exemplary in the type of depth and difficulty that they might expect to see in an exam. That way we know that they're practicing both the types of thinking and the sorts of things that we're going to be assessing them on so that they're prepared for that and practicing that type of learning behavior. Additionally, this gives us a lot of extra time because we've moved content before class. So we cover a lot of difficult material in this class, molecular structures and stuff. And this allows, we don't think lecture is inherently something that needs to be eliminated from the in-class time. And it can be instead focused on really difficult concepts that actually need more time to go through explanation from the instructors. And finally, we have things like these discussed with the neighbor questions where we have students zoom out and consider some of the broader themes of the course so that we're again asking them to think about the material holistically rather than really focusing in on facts that are sort of unattached from each other. And so to finish off this process, we've talked a lot about trying to teach our students the process of science. And in doing this, we've been sort of practicing the same sort of processes that we're trying to teach our students. So observing the world, observing our classrooms, looking into what is already known and what we can find out about that, and then experimenting. So trying new things in our classes and then observing how they change, how our students work. And so it's been really nice to sort of see this come together, and I just think it's really incredible that the types of things that we're trying to get our students to do is really a mirror about how we've turned the process of teaching also into a process of science. And so with that, we'd really like to thank all of the people that have been a part of this, Center for Teaching and Learning, the Presidential Chair as well as grant programs, especially the awesome people at the CTL, the cohort in this whole program, and also the other members of the MCB 136 instructional team who helped teach this awesome course. So thank you. We'll take questions.
I have a question. Can you all hear me? I actually have a few questions. I really find what you're doing in the classroom to be really exciting. The first question I have is the entry exit ticket the only form of assessment in the course? And then is it in any way graded? Because I think I find that fascinating that you're doing these kind of micro assessments.
Yeah, no, it's not the only kind. We had the entry and exit tickets. The grading structure is a little bit complex, which is why we didn't go into it. They get 1 point just for submitting the entry ticket. It doesn't matter if they get it right or wrong. They just get it for engaging. For the exit ticket, they can earn 2 points. So one for engaging, for submitting, and the second one if they get the answer right. So only a third of the points do they actually have to acquire the knowledge, but they have to be trying. And then we gave something like 15 or 16 across the whole course. And then we only counted the top 10 assessments. So they could get full points by not even participating in 1/3 of the entry exit tickets. That caused a lot of stress for them because we were trying to incentivize participation. In retrospect, this was not a good idea. So moving forward, what we're going to do is we're going to do entry exit tickets every single day. So they know it's going to happen, but they know that many of them will get dropped. So hopefully that will still incentivize them to participate, but without penalizing them or causing anxiety if they are afraid it won't happen. Then we also had midterms, but then they were worth lower comparatively. The problem sets were literally questions taken from previous year's midterms, and we told them they would be graded only for effort. They needed to try the problem. They couldn't copy and paste, Dante, but they had to put something in there that showed they were engaging, but then we did not grade it whether it was right or wrong.
Thank you. And just one more quick question regarding attendance. You obviously looked at the entry exit tickets for students who were in class participating. Those weren't, obviously there were differences in performance. I wondered whether or not, sort of two questions here, did this low stakes assessment improve attendance in the class?
Yes.
It did.
A lot.
Okay.
Like we went from less than a third of students attending every class to 75% attended almost every class.
Cool.
Yeah, this is because we were on Zoom. And so even though most of the campus was on Zoom in the fall, was in person in the fall, we were still on Zoom because of the large size of the class. And so that made it challenging for students to even attend because they were on campus, the Wi-Fi was bad, and most of their classes were in person. But they were really trying and to participate.
It's a terrific pilot, though. Anyway, I'll be quiet. I'm sure other people have questions to ask.
Thank you. I think our time is up. Is that right?
Your time is up, but there's a couple of questions in the chat that you might be able to just speak to briefly.
Yeah, what I was going to say is we can answer them in the chat. So we'll drop those answers in the chat for those who are sticking around in this room. Thanks, everybody.
Thanks.
Huge round of applause to this team. That was awesome. All right, now folks will have just 5 minutes of buffer time, and then I'll get set up with the next presentation.
During the buffer time, Evelyn, I can address your question about the process-based learning versus fact-based learning. But we've been sort of using this opportunity of like redoing course materials and also rethinking assessments to both provide more opportunities in class for students to practice things like experimental design and interpreting primary literature. And we're making sure that the assessments in the course are actually aligned with both the types, so they're both practicing the types of things we're testing, and the things that we're testing include more things like experimental design, evaluating data, things like that.
I think it does pose a special challenge because they need to know a certain number of facts to be able to design the experiment, think about a new line of inquiry, pushing the boundaries of what we know and what we don't know and how to acquire that new knowledge. And so that's been a real challenge for us too, is what's the right balance of fact versus application and scientific method.
And I'll just add on to that, that one of the advantages of flipping the classroom then is that, you know, they still need to learn those basic concepts in order to do these higher order skills, but we're allowing those higher order skills to be practiced in class when they can talk to their peers and they can talk to the professors, or instructors can even, you know, quiz people and see, is this problem making sense, and then have the real-time changes. So I think framing it that way can really help with those more difficult skills.
Robin's asking about discussion sections. So I was a GSI for this course a few years ago, and previously discussion sections are a free-for-all for the GSIs, so they get to do whatever they want. And we are considering, we don't know if we'll be able to implement this by fall 22, because we have quite a lot of work to do to sort of redesigning an entire course. But one of the goals would be to potentially, we're coming up with a lot of activities and not all of them can fit into class. So some of them we've sort of just bookmarked as like, this would be a good thing to tell the GSIs to do in their discussion sections. But at the moment, we haven't really touched discussion sections because we're focusing on the main course content.
Yeah, we did standardize this past fall what slides each GSI uses. So there was this, so we wanted to ensure the same information was being covered in each discussion section, but having the same activities is going to be really key. Great.
In the buffer time, I'm wondering if you all can speak to where you see this as possibly, you know, an educational research project going next, if you all had an opportunity to think about that.
I think sort of on a small level, we hope to, we'll see how far we get by the fall, but we hope to implement this and do the assessment and learn from that and really work on a regular basis to continually push these boundaries. The other thing is that Ellen and I are also designing a new course for upper division neurobiology students. And so we're going to hopefully use some of the same content and materials and tweak them a little bit for this related but different course that serves a different population of students.
Yeah.
So one thing we want to do is to think over the summer about our surveys, about our instructional assessments, so that we can be giving those throughout and really have some data. But to do this meaningfully, we need to write an IRB, I think.
Well, thank you so much again to the MCB team. If you don't mind, I'm gonna start sharing my screen, which might cut yours off. This next segment of presentations, we have colleagues from the Department of Art History, and unfortunately they couldn't attend today, but they recorded their presentation, and it's just so much great content and ideas and strategies. So I'd like to honor their work and their energy and show this recording here in this segment. And then I thought we could just discuss it as a group in the remaining time after the recorded presentation. So with that in mind, I'm actually going to reshare because I didn't share my audio. You think I would have that down? Okay, I think we're ready to go. I'm going to hit play.
Afternoon. Let me just go to slideshow here. My name is Professor Annika Lenson. I am in History of Art, and I am here to present to you details of our collective project titled Activating History of Art Teaching, Bringing Connect, Capstone, and Other Student Research Experiences into the Curriculum. The team for this project included myself, my colleague, Professor Jun Hu, and graduate students Angela Pastorelli Sosa and Elizabeth Fair. And our focus in this project lay in trying to create ways or find ways to create a learning community for students who major or minor in history of art, and to specifically give them dedicated pathways for developing and activating discipline-specific research skills. So what I have up here is a grid that we developed with in our first session with this fellows learning cohort, where we talked about the pedagogical or instructional change we were seeking. And our department is grappling with the need to make changes to our curriculum to fill a gap. This is the project motivation in existing learning experiences on offer. So we have large lecture courses, we have small seminar classes, and we have individualized honors thesis options, which students opt into at the end of the arc of their training in our department if they have a certain GPA. What we felt we were missing were courses meant to bring in students with a wide variety of backgrounds and levels of preparation into a space of research activity. So rather than passive learning or semi-activated learning in large scale lecture settings, we realized that our students, we wanted a way to motivate students along research paths with a different format and mode of course. And the shorthand for this project then is art history is for everyone. And the question is just, how do we ensure that there are pathways into the practice of art history, and specifically the research skills of art history having to do with visual analysis and close engagement with primary materials, including works of art themselves, and then an ability to ask questions about the context for the meaning of that artwork and the values that accrue to that artwork. How do we offer that to aspiring scholars from what will always be a wide variety of backgrounds, levels of preparation, and even points of entry into the major, for instance, transfer students, which comprise a large proportion of our cohort of majors. Working with Maricela Rodriguez in particular, and I'd like to give a shout out and thank you to her, our department and our working for curricular change developed 2 pilot courses meant to test ways to meet these needs. We offered the first in the fall. I taught that course. It was a 1-unit Connect style course. It's a low stakes course. We met a total of 7 times, and we really wanted to place an emphasis on community building, as well as introductions to resources on campus, such as campus museums, practicing activating materials there, and also archives and special holdings on our own UC Berkeley campus. As a way to make sure that we were planning the course, it's 7 meetings around the gaps, not only the gaps that we perceive in our current curriculum, but actually the needs and desires of the students in the course. Angela, my GSR, and I distributed a survey to students in the first class, and we decided to ask just 4 simple questions so that it wasn't overwhelming. And you can read them on the screen. What do you hope to gain? What is your sense of what academic research entails? What would you do first to embark on a research project? And this was a question we actually learned from our cohort this year in this Presidential Fellows program. And do you feel knowledgeable about the various career paths you can pursue as a history of art major? The most clarifying question for our planning was number 3. What would you do first to embark on a research project? You can see some of the answers that we got from the students in the course. They were very conscientious. They were thinking about how to begin research, but we noticed, and you can see on the screen, that the answers were overwhelmingly oriented to library-based research involving evaluating the strength of sources. So student imaginations, we discovered, were going first in the way they'd been trained to what we would call secondary sources. So synthetic takes by scholars based on those scholars' inspection of primary materials, so firsthand inspection and investigation in the field, so to speak. And we really felt that this revealed that students would need specialized invitations into work with primary materials. So that meant that Angela and I planned our Connect class sessions so that we would introduce students not only to resources on campus, but also the experts that work with those resources. So we had a dedicated session with our own graduate students to talk about their paths to research in the field. We had a visit to the Ethnic Studies Library and the Chicano Arts Movement materials there, and we spoke with an archivist about what it means to process somebody's papers when they're dedicated, when they are given over to a library, and so on. And in addition, we built in special career opportunities. Another way to welcome students into the major and insist that everybody belongs in art history is to show just the great variety of people practicing out there in arts fields. So this is a pick from a very successful career event roundtable that we'd organized with representatives from area museums. Our second pilot course that we offered in the spring was a 4-unit capstone course. And this was an effort to add an intensive guided research experience for all students, not just students who opt into the honors thesis project. The honors thesis project is an individualized solo effort. What we're seeking to add to our curriculum now are collective research experiences. And this course was developed and offered by my colleague, Jun Hu. And Professor Hu selected a remarkable collection in the Bancroft Library of more than 8,000 objects, falling under the rubric, The Chinese in California, 1850 to 1925. And this was to be the basis for the course for the whole of the semester. You can see a few examples of some of the really interesting print material that's in that collection. On the left-hand side of the screen and on the right-hand side of the screen, a picture of excited students in the course attending one of the several class sessions that they had in Bancroft with archivist Teresa Salazar. And we'd like to also give a shout out to Teresa's incredible knowledge and commitment to the class. The way that Professor Hu structured the course included some skills-based development, looking closely at an object and learning to describe it. It also was a course that developed through individual research paths around objects, but with an expected collectively authored public outcome. And this is to be a virtual guide to some of the materials in the collection that will be published at the end of the summer. Right now, we're still in the middle of the semester and students are finishing their projects. Over the course of the semester, students gave short presentations, written essays, did a field trip to Angel Island, and worked together to develop not only their sense of what they wanted to author, but also to develop their sense of ownership over this collection or engagement with the collection. Professor Hu reports the overwhelming quality of the 8,000 items was an interesting motivation to the students because they feel that once they've written a guide to some of the key pieces, whether it's by translating languages that they may have or highlighting ways that individual objects connect, that this will be a guide for those who come after these students. So it's a way to insert oneself into the actual chain of knowledge production as a guide, as a sort of enabling and generous gesture on the part of the course. We talked a lot about how to assess the success of these projects in our cohort. And what Professor Hu and our group decided to do is do a series of structured exit interviews with students in the course. And Professor Hu focused on the question of community. We found that students often want to make friends. They want to understand themselves as part of a learning community and a cohort. And our question is how to make the idea of friendship into something we can really measure, pay attention to student needs, and also yet keep it academic. Other questions had to do with the understanding of research that we'd highlighted in the fall. And then self-assessment of the skills acquired. What do you feel you've learned? What can you do now that you couldn't do before? And we were really pleased in particular with students' sense that they'd finally understood what research could be in the field of art history. So one student here observes that simply paying a single visit to a museum is not a research experience. It's returning to the museum and adjusting your hypothesis with each visit and with each further engagement with the objects that constitutes research. And student B, and both of these students were transfer students, the kind of group we're really trying to reach. Student B reports that they knew they were transferring into a research school, but weren't sure what that would be. And now getting the opportunity to go to the archive, learning how to request access to material, knowing that it's there for them to use. Studying objects, not just as slides on the screen, but firsthand, really transform their sense of what is possible. They feel they have a possible career path even in either art conservation or as an archivist. This was important to us. It's not like art historians are only academics. Art historians can be custodians in the field working with things in a variety of institutions, and we want to make that vivid for students. The same student also noted that the guided research course is like the humanist equivalent of being on a team and working in a lab. And at a university that often feels very STEM centric, this was a delightful quote, and also really key for our department's thinking going forward. Can we continue to hone the idea of the equivalent of a lab? How to make this kind of work less lonely, remind students that you can work with one another on a question of shared concern. So we were quite pleased with these outcomes, and our challenges now are how to convert the pilot courses into something lasting in our curricular redesign as a department. Some of the challenges revealed by the pilots, some short-term ones just include basic access to collections on campus. There's a large demand for research appointments, how to adjust for that if we're designing entire courses around the presumption of access. In the intermediate term, any public-facing project, even a website, which can feel inexpensive, of course, requires upkeep and some sort of planning for the life of a public project. So the department will have to think about budgeting or partnerships for things like hosting a web portal for the project, the professor whose class is working on, or future projects. And in the longer term, faculty teaching load will be something for us to work through. Given our expected teaching loads of 8 units a semester, who can we bring on to teach something like a 1 unit, 2 unit, 4 unit course of this distinctive kind? And how can we make sure we have GSR support in the current funding environment? This will be a bigger question for the department to work through and think about weighting and how we recognize our unit count, not just departmentally, but in the university. So next steps for this project, in the fall, I'm teaching the equivalent of another pilot, although not without the help of the fellows cohort. And that's going to be a new and updated version of our Theories and Methods course, History of Art 101, where we'll continue to build in pathways to research experiences and disciplinary specific skills. And our sense of how we're going to evaluate the success of these updates to our curriculum. Well, we learned through the course of the semester meeting with one another that it's always, of course, crucial to refine our problem. And in the case of History of Art is for everyone. We've talked a lot about what we're really trying to do. Are we trying to increase interest campus-wide in taking our courses? Are we trying to have more majors? And our answer is, we do want to increase our enrollments. We think art historical research are skills for the future that every student should have on this campus. But concurrently, we're not necessarily looking to bring in extra majors. What we want to make sure is that we are training our majors better with more activated, discovery-oriented skills. And the other key thing that we're going to implement is we're going to design an exit survey for majors so that upon graduation, we will continue to ask these questions about what is research to you? How would you assess the skills you learned? What can you do now that you couldn't when you entered our program? And our hope is that over time will allow us to continue to refine our pedagogy. So I'd like to thank everyone who listened, and especially like to thank my team members, Junhu, Angela Pastorelli-Sosa, and Elizabeth Fair. It's been a real pleasure working on this together. Thank you.
Okay, quite a powerful project of so many different elements, moving parts, and from just my take on it, quite thoughtful findings around community, friendship, all surfaced around undergraduate research. I'm happy to just open the floor for any thoughts that folks want to share, how these themes might resonate with you and your department's efforts to enhance undergraduate research, or any questions that you'd like to put in the chat for everyone to discuss together.
I'll just say that I was really excited that they were focused on transfer students. I think transfer students so often fall through the cracks and don't get the same opportunities to do research, and finding ways to help them in a much shorter amount of time build identity as a researcher and explore those opportunities is really inspiring.
I was really impressed that they were able to launch 2 pilot courses within a year. That's so ambitious compared to our like 10% of our lectures. And what I really loved about their project is that they started with this question that's really simple. Just what is research? And, with our students, I don't think we start that simple, but that's where we should be starting, is really what is research and what does it mean?
Hi, not able to have video, but I have a broad question and I'm trying to remember how they phrased it around in the challenges at the end around basically just scaling this project, around like, what does it mean to expose as many students as possible to this kind of research? And I'm from the Discovery Initiative and the new Discovery Hub. And, I'm thinking through what does it look like to engage every student in active learning or project-based learning. And I'm just curious, some thoughts around kind of the scalability of that, and like what students are reached and who isn't, and what does this look like as a campus-wide, initiative or pedagogy. So that's a general discussion question.
I mean, I'll just jump in and say, like, I like you raising the issue of scale. And like, I think that particularly as a public university, like this is, I think, one of the biggest challenges, because like the university has a mission to try to reach a lot of students. And it's also like in thinking about scale is where a lot of people tend to like shy away from like intervening in their classrooms and doing these like cool things, because it's really easy to do it with like, or not really easy, it's it's much easier to do it with a small amount of students. So I love that that was part of their sort of analysis. Like it's, how do you pilot this and then how do you make it reach more people?
One thing I thought was really cool was the authenticity of like when the students were creating that guide, and that the students could feel that, this is something that could pass on to the next student, so you can be more engaged in that project. So regarding this question of scale, I'm thinking about like, do you miss out then on some of the authenticity if you're trying to just make sure that this is reaching a huge number of students? So curious what others think about that.
I think in thinking about scale, I think it's really important for students to be sort of primed to think about the research process in the very first, at the very first level when they first come into the university. So even in the foundational courses, they should be getting some ideas about snippets about the discovery process, so that by the time they get to their upper level courses, they're primed and ready, and it's not so scary and foreign to them. And then the question is, how do we bring our transfer students to that same level? And that's something we've struggled with or started to think about in physiology. Could we have some kind of a physiology boot camp for the summer before our transfer students start, for example?
Thank you for all of these great thoughts. I'm just going to acknowledge that we're now in the buffer time if folks would like to jump to a new room. But I'll also say that I am still thinking about that question of, what does research mean or look like to our students? This is humbling me because I've never asked my students that, but to see that student response of what research means to not just visit a museum or an archival piece once, but to do it repeatedly and reiterate and think about that process. Oh my gosh, I'm just so shocked by that. That's such a great way to think about it. So maybe I'll end us on that note, but I welcome folks to continue chatting or jump to a new room.
Welcome, everyone. We're going to start with Michael.
All right, yeah, you can go on next slide. So currently today in most of our intro courses, that's 61A, primarily for the purpose of the study. I'll also talk about CS88. We have a lot of coding exercises, labs, and homework assignments, and they mostly start out with an open-ended response. It's great for practicing code writing, but starting from a blank slate is obviously pretty intimidating for students, and there's not as much scaffolding that as we would hope. So next slide. The approach that a lot of folks in the computer science education community have adopted and experimented with over the last few years are these tools called Parsons problems. They're two-dimensional sort of drag and drop tools that let students build a solution line by line, including experimenting with things like ordering effects, indenting code, since the indentation from left to right matters in most programming languages. So we've built upon some of this work. And if you go on to the next slide, at Berkeley, what we've done is adapt some work by a PhD student, Nate Wyman in the ACE lab, who is defending his dissertation next week based on some of this work. And what he's done is add this component of a fade to a Parsons problem. So it takes this idea of drag and drop, and it adds essentially blank inputs to the questions. And so this gives questions quite a bit more difficulty in terms of expanding the amount of responses, and it prevents students from just brute forcing a solution by reordering lines of code until the test pass. So it gives us the benefits of scaffolding with the ability to have students actually think about their solution, because what we've seen from students is in a course with the limited attempts, they might just reorder code until the test pass. So we did some early work with Nate in CS88 that proved pretty successful. One of his findings there was that students can improve their code writing ability similarly to open-ended code questions. But in CS88 at the time, many students preferred this drag and drop approach to just open-ended code writing, at least in terms of giving them practice. And Pamela will share, and the students will share some other similar feedback from this semester. So next slide.
All right, so I'm the CS61A instructor this semester, and we integrated faded Parsons into 61A by adding them to each of the lab assignments and homeworks. And so how that would work is that, typically the labs would have code writing questions. And so we came up with Parsons problems that would scaffold to each of these code writing questions. So they would have a similar structure to the solution as the code writing questions, with the idea that students learn the structure in the Parsons problem and then are able to recognize when they should use that structure in code writing. So here's how it looks like when students are actually, working through the Parsons problem. So there were, 2 code writing. So there's 2 required Parsons problems. So here's one of them. So they get the description of the problem. They have the blocks on this side, and, they can start dragging them over and trying out different things for the blanks. And let's just make sure we don't have an infinite loop. And then they can run the test to see how they've done. And they'll get feedback on that. So that's how we integrated them into 61A. Yeah, okay. So, and then every time they ran the test, we would see their information in our submission system, and that was data that we're later able to analyze. So we are looking at whether they worked, and one thing that we looked at was actually asking students surveys throughout the semester, both on the mid-semester survey and the final survey. And one thing we asked was how long students were spending on Parsons problems to try and get a feel whether Parsons problems were a good use of students' time. Because one of our hopes is that, if they spent maybe more time on Parsons, they would then spend less time on code writing. So you can see the distribution here for how much time people spend. It was between 10 and 40 minutes, which is actually a fair amount of time for these Parsons problems, but they are quite tricky, and they do have to come up with blanks for the fades. We then broke it
break these results based on how people did on midterms. And what you see is that, folks who, did worse on the midterms are spending a lot more time on the Parsons problems, whereas folks that, did better are spending much less time on the Parsons problem. So that was very interesting to see. And this is also how their self-perception. This is, them self-reporting. We also asked them, how much do you think the Parsons problems prepare you for the code writing questions on each assignment? Because that is the hope of Parsons problems, that they are a method of scaffolding. People, generally arrange them around 3 to 4, which is on the higher end of the spectrum. And we broke those into midterm scores. And interestingly, folks who did better on the midterms thought that they prepared them more. So maybe we aren't actually doing as good of a job with scaffolding folks that are struggling more with the course content. So that was quite interesting too. So then we want to do some quantitative data analysis, see, okay, this is what the students reported, but what does our data show? Like, are they actually, is it actually helping them with the code writing questions? So in order to do this analysis, we didn't do an A/B test within the class just because of the difficulty of splitting students up into different experiences. Instead, what we decided to do was compare last spring semester to this spring semester. And the reason we do that is because fall and spring students are very different in terms of experience levels, whereas spring students tend to be much more similar in terms of experience levels. So we always like to compare spring to spring whenever we're looking at performance in 61A. But notably, there were still big differences between spring 21 and spring 22. Spring 21 was entirely remote. That was one of our COVID semesters. The lecture was basically a different lecture because I only did a few lectures. Lab participation was optional then, now it's required. And the lab format was quite different in that TAs actually walked students through the solutions in spring 21. So that has a big effect on how you're able to succeed in that. So we need to keep all of that in mind when we're doing this analysis, is that we're not, we're not comparing apples to apples, we're comparing apples to pears or peaches or something. So with that in mind,
yeah.
Go to actually Anirudh, yeah.
Yeah, for sure. So I think our main hypothesis, like Pamela referenced before, is that if a student completes a Parsons problem about a certain concept, then he or she can complete a similar problem, which is a code writing question with the same concept, but in less time, basically. And the one thing to note is that we did not have Parsons problems last year. We added them this year in this semester, but we had code writing questions in both last semester and this semester. So like sort of to compare between the data. And we wanted to compare performance based on 2 metrics, the time spent and also the number of attempts. But the thing we noticed is that time spent is sort of noisy. So we wanted to focus more on number of attempts because that's like more straightforward. It's more like singular. If you go to the next slide, I can sort of talk about like why we chose number of attempts, because we had like both time taken and number of attempts. We compared both of them like through this plot, and it sort of makes sense because as the number of attempts increase, the time spent also increases. So that sort of gives us the confidence that like, oh, okay, we can also settle on number of attempts for like our main metric to compare student performance. Yeah. That's it, yeah.
So here's an example problem that we looked at. On the left side, there's a histogram of the number of attempts that a student spent on this problem in spring 21. And then on the right side, this is spring 22. And if we read the summaries at the bottom, you can see that in spring 21, students had an average of 2.6 attempts on this problem. And in spring 22, after we added the scaffolding through a Parsons problem, students had an average of about 2.26 attempts. And maybe you could use this to say that like the previous Parsons problem improved a student's understanding of a particular concept. And when that concept came up again in this code writing question, then they were able to do it in less tries. Next slide, please. And so that was just one problem. We looked at this over like all of the problems that we attempted to scaffold. So there's 11 problems on this slide. And what I've displayed here is the difference in the median number of attempts between the 2 semesters. So it's the median in spring 22 minus the median in spring 21. And you can interpret like the green results to mean that there were more attempts in less attempts in spring 22 versus spring 21, and red to mean there were more attempts in there. And so green is a direction that we would like if we were arguing that Parsons problems improved understanding. You can see that there's a handful of green results, also a handful of red results, and I wouldn't say there's a clear direction so far. And so one thing we need to do is step back and consider some confounders. So as Pamela mentioned, there were a ton of changes across semesters. And we noticed these like in specific problems as well, where we had significant differences that weren't immediately explainable. So could you go back a slide, please? Yeah, so as an example, we had this problem lambda curry 2, where the solution actually appeared in the lecture slides in spring 21, and it didn't in spring 22. And we had another problem, has path, which had a much longer hint video in one of the semesters. And so what we did after this is we sort of removed these 5 problems, which we identified had confounders, and we got the following results. Out of the 6 remaining problems that we compared, we found that 4 had a significant decrease in the number of attempts that students spent, and 0 had a significant increase. And we also compared 8 problems that just were non-scaffolded. So these were problems that served as a control. We didn't have corresponding Parsons problems that would like improve student understanding of them. And so in this set, we still had 2 significant decreases and 1 significant increase. But you can see that like a large fraction of the scaffolded problems had a significant change, while not so much in the non-scaffolded control group that we used. Next slide, please. So some conclusions from this. There's definitely some indications that the Parsons problems provided some meaningful scaffolding for the code writing questions. We can see that we decreased the number of attempts in a statistically significant way for 4 out of the 6 problems we looked at. But I also want to mention that it's entirely possible that a lot of these cross-semester differences were driven by other factors. And the reason I say this is because I identified a handful of confounders, and these were the ones that were sort of easy to pick out, and so I removed them from the analysis. But there are certainly many, many more differences across semesters. In general, it's fairly difficult to do a meaningful quantitative analysis here because we don't have a randomized control trial setting. And yeah, there ends up being a lot of confounders.
Right, so another metric of student performance that we analyzed was wheel spinning, which, next slide, was generally when, sorry, next slide. Which was generally when a student had some pattern across all of their submissions, which indicated that they were changing around lines of code without necessarily some underlying motivation behind their changes, and not making forward progress towards a solution. So looking at this example student's submissions, we can see that in the span of 2.5 hours, they have a very high number of attempts where each of these dots is one submission, as well as how similar it was to the previous submission. And they have a very high number of attempts relative to the averages we saw. And these were also very frequent, so very like high concentration of dots. And furthermore, most of them were very similar to each other, with just a few submissions which had significant changes from the previous one. Next slide. Unfortunately, we were not able to conclude whether the scaffolding decreased the amount of wheel spinning that we saw, partially because of the availability of features. So we mainly analyzed text, which is the actual code that the student submitted. And there was a lot of variance in like what a text-based change actually meant in terms of the code, where maybe a small change was actually a large step forward in progress, or like change how the code would execute, whereas differences in the student habits, for example, some of them might copy paste like their previous work or attempts, whereas some of them might like change a lot of variable names, would mean that a large change in the text itself did not necessarily mean that they weren't wheel spinning. And in the future, we might instead look at their actual test results or the program structure on each submission. Next slide.
Okay, Michael?
sorry, muted. Yeah, you can go ahead. So I think a lot of the things that we were thinking about for the future are ways in which we could both improve the research and the sort of integration of the tools. So one of them is in our setup, we replaced a single problem, or we added usually a single problem that corresponded to an open-ended problem. So what we'd like to do is really sort of invest in the scaffolding, where we have multiple approaches in Parsons problems that would help with that. And so far right now, most of our feedback has focused on these unit tests. So there's a bunch of research that suggests that there are better ways of providing adaptive feedback, such as suggestions on what lines to fix, as well as feedback that corresponds more directly to an individual line of code. So those would be sort of future research improvements. And the one thing that we sort of skipped over was trying unfaded Parsons problems, or sort of classic Parsons problems in our courses, primarily because Nate's research is really promising, but on a scale of no scaffolding to tons of scaffolding, we could probably explore the wider ends of that spectrum. So next slide. The second part of sort of future work is really to sort of improve some of the ways in which we're able to do analysis. So in the future, we're really considering doing some more A/B style testing of Parsons problems in our courses, which should probably mean assigning students the same exact question, but randomizing whether or not they get a Parsons versus open-ended code format. And doing that right would probably require IRB approval. And in terms of future research opportunities, the tools right now have decent logging, but there are a lot of places where the data analysis was not sort of set up to be easier from the beginning. So another student working in the ACE lab, Logan Curacao, is working on adding some logging to other tools that use Parsons problems. So that would be a space, and also aggregating and logging the individual test results from each attempt. So not just when and what they submit, but the results of each submission would make it easier to do some analysis there. And we also have some thoughts on potentially better survey questions for trying to segment beginner and advanced students. Cool.
Okay, and that is all we wanted to show today. We have 3 minutes for questions. Thank you everyone for listening. It's been a really interesting project over the last year and a half.
I'll jump in with a question for you all. I think it's so interesting, especially given your disciplinary background, the different ways that you can get windows into this huge class, and thinking about the different ways that students are approaching problems, like how long they're taking, how many attempts they do, and getting a big picture of what that looks like across the course, students in the course. I'm wondering if you've considered pairing that with also a peak that would give more qualitative data, like a think aloud problem that would maybe be a nice complement to, or other ways that you might unpack some of student thinking about the problems. I can't remember if you said you use surveys, but that might have come up.
Yeah, so we did have the surveys, but one recommendation from someone we talked to who does a lot of Parsons research is doing think alouds of the Parsons problems, just to refine the problem design. Because I think one possibility is just that we could be coming up with Parsons problems that are better scaffolding, right? So that's definitely something that would help us design better scaffolding. Yeah.
Yeah, and I think there's what we discussed was primarily for the approach to design. I think it would be really interesting to try. Historically, I would say most of our computer science courses have, let's say, diverted from approaches that require students to be sort of in a lab or working, pretty closely with TAs. We definitely, want students to attend lab, and most of them do consult with peers. But the challenge between sort of asking students to do this work and assessing or grading it at this scale has meant most of it hasn't happened. I do think it would be fun to try and see what happens if we asked every student to at least sort of give their experiences and perceptions.
Yeah, we should note that this class has 1,000 students in the spring, and this is the small version. The fall version has 2,000 students. So that is why there's a kind of big emphasis on what can we do in a scalable manner. And yeah, that does complicate things. Yeah. But I think it's useful even if we could talk with some students just to get a window, because even talking with a sample of students can help you develop a lot more insight into trying to understand the data. Mm-hmm. Oh, there's a hands up.
Yeah, Andrew, go ahead.
Yeah.
Yeah, I just had a question. I look at these sort of differently scoped problems that you can put in front of your students, from very structured to not very structured. You have lots of, it's a very continuous spectrum that you can tinker with there, and that strikes me as a really valuable laboratory in which to work. You can really dial in that scaffolding kind of on an individual student to student basis, really. And this is for teaching students fundamentals of writing computer code. And I'm wondering, you both also teach upper division courses that get outside of just teaching students how to code. I'm wondering how transferable you think this laboratory of pedagogy is to outside of teaching students how to code. Like, can we use this general, really dialed in, kind of customized, largely algorithmic approach to teach complexity, to teach fields outside of CS?
Well, so I recommend looking more into Nate Weinman's work, because he's also working on Parsons-like problems for upper division classes in terms of like high level architecture of things and kind of the flow of things through systems. So understanding, like for model view controller for software engineering, like understanding how the data connects to the view and that sort of thing. So that's still a CS application, but it's just the idea of giving somebody some sort of structure within which to it describes something, and it's a drag and drop type thing. So it's a form of scaffolding that could be used for other things, and you could imagine using that for other things, like anything sequential. Yeah.
I think there's also, Pamela said what I was going to add about Nate's work. Logan is going to be taking on some of that. This is all with Armando Fox, who is one of the associate deans for data science now. But this fundamental idea of I think what the Parsons tools are really leveraging is essentially a very sort of micro version of a workflow from A to B, with some sort of tweaks for repetition and other constructs like that. But fundamentally, actually, what's being we're turning the code or the blocks of code into runnable code and executing test cases on it. But really, it's more that the tool is sort of set up in a way that 1, 2, 3, 4. You have sort of some ordering problems. So there's there's classical versions of just put items 1 through 5 in order or something like that. That I think you can find analogies to in other disciplines as well. So there's a bit that's code specific, but I think the ideas here probably do translate pretty well.
Yeah, we actually, I developed a lot of courses for Khan Academy, and we have a orderer widget that we use across all the disciplines at Khan Academy for that sort of thing. Diana, you have your hand up?
Yeah, great talk, really interesting studies. I'm really curious about this feedback about how long it takes. We got a lot of complaints, even when we gave a previous exam that was performed in class that took 1 hour, students reported taking anywhere from, 3 to 30 hours working on it to complete it. And I like the hints that they get, but what other strategies you have, and how are you going to use this feedback that you get about how long students take?
Yeah, that's a really tough and interesting question. So one of the things to know, I guess it's context, is all of the take-home work in our computer science classes, intro through upper division essentially allows students, infinite attempts within a constrained, submission window, right? Assignment goes out, it's due at some point. And so in CS 621 and 88, students have full feedback where if they see a passing test, they know that something's, or a failing test, or they know that something's wrong. If they see a passing test, they know they've earned the points, right? And in our lower division courses, there's nothing hidden about that. Fully passing tests is a fully correct score. And so I think what we also see is a lot of students will spend as much time as they possibly can to get a full score. Partially, we have this problem for the majority of our students, there's a GPA barrier to declaring what many see as a financially lucrative major. So the incentives for time spent, I think, sort of outweigh some of the assignment design. Beyond that, I think our hope is directing students' approaches, and that was primarily with the wheel spinning stuff, where if we could detect that a student is spending their time less effectively, then we could direct them to additional resources, feedback, TA help. And if they're working in lab, that happens with lab assistance and smaller interactions. But so much of the work happens at home, for these students that it is hard to get sort of a picture into where students are really sort of going from productive work to sort of unproductive time spent on the assignment.
I want to interject and just do a virtual round of applause for this team and all of their wonderful findings on this project and their effort. And I want to invite.
We have a few members of our team here, and we're going to try to do the same, tag team presentation with just me driving the slide deck. So we'll do the best that we can here. Ari, would you like to take it away?
Yeah, hold on one second. Let me make sure I have the notes for you to kind of do that. Okay. Okay, all right, I'll get started. Okay, so thank you all for having us here. I'm going to introduce our project, Social Practice with Data. We're going to pass things back and forth a bit. So just a kind of quick intro before we get into details. What we've done here is design a sort of suite of curricular interventions for several foundational data science classes, aiming to seamlessly stitch together statistical, computational, social scientific, humanistic, and ethical modes of thinking to teach students data science as a kind of holistic, socially context-sensitive practice. And to do so in a way that avoids siloing these different modes of thought into sort of separate, like humanistic and technical courses. Of course, that distribution exists, but through the different courses, we wanted to use, as we've shown here as this kind of hub and spoke model, use one particular central case study to ground this sort of interdisciplinary context, a specific mode of instruction and learning for students. And in so doing, to see these different aspects as a kind of unity, that the humanistic, social scientific, computational, and statistical operate together as a kind of unity in defining what responsible data science practice can look like, and actually doing that together with students in some of the core classes. So we've designed the work we did around a single real-world case study involving sort of publicly available real-world use case data on which students learn to develop predictive models that have very real practical applications in social and ethical stakes. And so more than just learning how to design something on real world data, the interventions we've made in these projects for some courses are really designed to specifically address issues of social justice that crop up quite often in a lot of real world data science applications, as well as emphasizing collaborative learning by placing greater emphasis in the curriculum design on discussion section orientations. Okay, with that, we're going to kind of move and dive into some of the little spokes around this central case study hub.
Great, thanks. Yeah, so all of our work has been around one main case study. This has to do with building predictive models for house prices in Cook County. And we'll get into the details of that case study in just a moment. But I just want to start with some background on the data science program itself, kind of the medium in which this case study is being tested out. So let me see, there we go. All right, so yeah, the case study, it's found its way into 2 courses in the data science major so far. And just to give you some background, the data science major at Cal incorporates technical foundations and the study of human context and ethics, along with more than 24 domain emphases or areas of application. So I'd say there are a few notable aspects of the data science major that are useful to know about our project. One is just that it's large. The scale here is large, as in the previous presentation. Although this program is only a few years old, there are more than 800 data science majors this year at Cal. The other is that it's unique kind of across higher ed, and that its genesis was strongly interdisciplinary. That's to say it's not just a riff on the statistics major, it's a result of bringing together faculty from statistics and computer science and School of Information and social sciences and history and philosophy that came together to put together the courses that make up the major. So it's a very interdisciplinary program, and therefore our team is also very interdisciplinary. So Catherine Carson's been working on this project. She's from history, RE, trained in history, but working now in data science. Renata from the School of Law, JD, PhD, studies algorithmic fairness. Dave Harding from sociology, who's the director of the D Lab that deals with data science in the social science context, and myself in the statistics department. And I guess the other bit of background to give you is just a few of the courses maybe that we'll mention and that this case study has come up on, and the courses that we've been working in. They are, well, I guess the foundational course, which we haven't so much been working in, is called Data 8. This is the Foundations of Data Science. This is the main gateway course into our major. But after the introductory course in the upper division, this is really where we start kind of siloing a bit, where that interdisciplinarity breaks down a bit. We have Data 104, and this is a course that's designed around getting students to use the tools of applied historical thinking to recognize, analyze, and shape the human context and ethics of data. This is a course that Ari and Catherine have taught before. But then students also pivot and take Data 100. This is a course that I've taught before, and this covers key principles and techniques of data science, like querying, analyzing data, algorithms for machine learning, principles of data visualization, data collection, measurement error prediction, scalable data processing. And kind of the tension that we've realized is that, you know, some of these most interesting case studies you can't deal with them only in one of these 2 courses and do them justice, because they have pretty sophisticated kind of technologies going on the you know, statistics, computer science, machine learning side. But also they're embedded in a really rich and complex social context that if you're just focusing on the techniques, if you're just seeing this in Data 100, you're not getting the full picture of it. So I guess I should say this case study that Ari is going to talk about in just a moment, it originated in Data 100 and originated just kind of focusing on the technical side with a few kind of efforts at giving students exposure to the human context and ethics. But as you'll see, it's very complicated. So it's been a question for us of how do we reconcile a complex study? How do we set up our Data 100 students to succeed with this case study that has this rich human context? All right, so let's get into the case study itself.
Okay, so we've made reference to this case study. It's something we've been working on for a while in and around Data 100, and it's meant to replace an older case study that used a similar kind of data set, that is one involving property characteristics, with one that was both part of a more real world attempts at social change using data, as well as just a sort of richer context around what's in the data and what it represents. So the case study is based on this real world open data project at the Cook County Assessor's Office. That's roughly Chicago and some of the surrounding areas. This particular case was actually discovered by one of a former student team members on our human contexts and ethics team, who was looking for something kind of rich to replace this classical Ames, Iowa data set that's kind of a canonical case for teaching certain statistical methods. And so basically, what our student discovered was this sort of open data system that exists online that had been developed in part to try to fix a corrupt system that in Cook County that had been reinforcing historical racial and wealth inequalities. So what exactly is this case study? Well, it first came to public attention in 2017. A team of journalists and academics had teamed up and basically uncovered and then publicized a pattern of regressive residential property value assessment and taxation in Cook County. In essence, to simplify things a bit, lower income and predominantly non-white homeowners were being taxed at higher effective tax rates than the wealthier, whiter homeowners. The regressivity was partially due to the kind of very simplistic models that they were using, but it was also due to the particular structure of an appeal system that in complex ways was corrupt. We won't get into the details here, but basically this came to light and actually sort of prompted the election of a new county assessor because of the kind of public controversy that came to light. Essentially, a new county assessor was elected with a mandate to reform and rebuild the system. And he centered this sort of proposal for how to address these kind of entrenched inequalities that were being kind of repeated and exacerbated by the previous system by constructing a new open data team that would use a sort of massive amounts of sales and property characteristics data to more accurately predict residential property values for the purposes of tax assessment. And they wanted to do this in a kind of make all the data open, make the entire system and workflow open and transparent so that community members in theory could go in and look at it, but also to sort of show how sophisticated the predictive model is to kind of publicize the kind of metrics for assessing accuracy and fairness of the prediction models that they were building. Basically make this fair, make it transparent, kind of legitimize the now delegitimized county assessor's office. So we brought this in and used it to sort of replace this old data set. And so students here learned to use the Cook County assessor's office data to learn how to train models to make more accurate predictions. But in so doing, they're required to learn about the social context, the stakes, and complexities that are involved in actually building a system like this. That is, it's not simply go find the single correct, most fair prediction, but actually understand what's involved in doing this. Why does it matter? Who's most affected, among many other things. So with that, we can actually go and take a closer look at some of the learning objectives that we've built for this. So for the sake of time, I won't dive into each of these kind of subtopics. I'll just kind of give you an overview array of what some of the key learning objectives that we had formulated to ground this project look like. And in essence, so the point of this, of course, is to try to really bring together these two different types of learning objectives and make them more or less indistinguishable in the course of actually teaching students to work through this kind of case study. So in part, it's about getting students to just even learn a little bit about like what's in the data. Why do you bother predicting housing prices and for what end? What's at stake? Who's affected by various design decisions? What constitutes a fair output of a predictive system in a particular context? So to actually get to these things, we kind of broke this up into part of what students are just learning is to understand the context in which they do really abstract technical work. So the first learning objective in HCE here stands, by the way, for human contexts and ethics. And then we kind of put tech just for the kind of more traditionally statistical and computational techniques that students learn. So just basically learning the context of the case study, comprehending the basic outlines of this open data initiative, in part through lecture materials and through things that we embed in notebooks. Learning more about the complexities of the concepts of fairness, thinking about fairness not as a simple, definable, operationalizable and a category, but as a socio-technical concept that really depends on the particular systems that one is building, and that there are multiple different concepts. So part of the goal is to help students disambiguate and evaluates several closely related concepts that sometimes are called or defined as fairness, but have specific meanings, whether it's accuracy or bias, different notions of accuracy, and at what level of analysis we talk about things like accuracy. And then, of course, understanding the respective implications and possible impacts of each different notion of fairness, as well as actually getting to the limits of fairness as such as a proxy for thinking about housing justice. Beyond that, we get students to think about the interactions of data, race, and social structure, and thinking about things like race as a social structure that's that is a kind of a structure that's deeply embedded in housing markets and their histories. So we hope to get students to reflect on how models and data-driven automated decision-making systems basically complexly interact with these different social structures. Race, income, and wealth central among them. And then finally, on the HCE side, to help students think about how, what the kind of opportunities and limits of using data science techniques, such as what the Cook County Assessor's Office does, to actually engage data science expertise in public projects for social change and social justice. On the technical side, the projects that are centered on this case study teach things like residual analysis and model diagnostics, loss functions. So students learn to fit a model using multiple loss functions, evaluating the impact that each loss function has on the resulting model, and selecting a loss function that maps well onto the specific contexts of the data that students have learned about. And then students also learn to think about the impact of feature and variable selection on their model development. So they'll explain the impact that the inclusion of particular features and variables have on their resulting predictions, and interpret, crucially, what their coefficients explain about the data. So those are kind of the broad level learning objectives that we are trying to get to work in the projects that we've developed for students. So now we'll tell you a little bit more about what those projects, like what the elements of actually teaching this in practice look like.
Great, thanks so much, Ari. So the elements of the case study were threefold. First, there were Jupyter notebooks, and these are essentially ways that students can play around with the data to answer particular questions. There were also discussion questions in order to generate conversations around race rather than it being something static that you're only seeing in a notebook or that you're only receiving, allowing students to really be a part of the conversation around redlining, racism, and so on. And finally, there were recorded mini lectures. So these mini lectures were really trying to contextualize the social sort of history and current practices around housing discrimination in order for students to have a common point of departure to engage in these conversations. So specifically, conversations around covenants, for example, that excluded Black folks from certain neighborhoods, as well as histories of redlining and current practices where Black folks and people of color are appraised at lower rates than their white counterparts. We're going to look at one example specifically, the notebook example, if we could double click on that. Fantastic. So here we've embedded this GIF where you can take a look at what the Jupyter Notebook actually demonstrates. So it has a couple of different parts. It starts off with asking students about their intuition around the data. What do they think the data is going to show? Why was it collected? That sort of thing. And then it moves into actually doing some exploratory data analysis. So trying to find relationships in the data that relate back to their sort of initial hypotheses and understanding of not just the technical components, but also the socio-technical components around what motivated data collection, what were the end goals, and trying to find sort of the limits of, the limits of using technical tools to understand social issues. So this has been it's been a kind of collaborative, interdisciplinary approach to problematizing these issues, and the Jupyter Notebook is one of the sort of artifacts of this process. And with that, I will let the next person go.
Great, thanks, Renata. So we just have maybe a minute left. I just want to touch on real briefly the last two components of our project, just assessing. We kind of developed these new curriculum materials. How did they land? Did they accomplish what we wanted? And then how this has us thinking about instructional design. In terms of assessing the project, you can imagine, okay, well, we're wondering, did our students actually emerge with the understanding of this case study that we'd hoped? And we actually haven't engaged in this part of the assessment yet, but we'll be reviewing a sample of the student work on what was called Project 1 in Data 100 this spring semester, when this kind of new version of this, this case study was deployed. And then the other that we've started to look into already is student perceptions of this. So Data 100 has a very rich internal course survey that asks for students' feedback, lots of it very unguided. And it came up, I'll just summarize by saying that the project, the housing project came up both as students' favorite and least favorite assignments. I'll just click through these really fast. Generally the least favorite thing actually didn't have anything to do with the social context. It had to do with kind of a mistake that was made in making it a little bit too challenging, one of the technical aspects that caused lots of frustration for students. So I think that kind of hogged lots of students' attention in this for good and bad. In terms of its favorite, students that said that they liked it, they're really focusing in on the real world. You know, they feel like they're actually doing data science. They see the impact in the real world. So that anyway is ongoing research. Lastly, just around instructional design, something that we realized is, you know, it's one thing to create curricular materials. It's another for our students actually to be engaging with them in the manner that we would like them to be. And in these very large courses, often it's largely kind of an autodidact design, courses designed for students largely just kind of learning on their own. You know, engagement in live synchronous sessions, either discussion sections or lectures, is quite low. Most students are working through these assignments largely on their own. So we wanted to, you know, get more engagement with the students, particularly around these discussion questions that we're writing. Because if we're asking the question like, how much is a house worth? Who might be interested in the answer to that question? Please list at least 3 different parties. Or if we're asking about how this is placing a disproportionate tax burden on non-white property owners, students just answering those on their own, particularly in a technical class, we're really not setting them up with the skills or the environment to engage with these questions in the ways that we'd like, and the ways that, you know, lead to responsible conversation in data science. So this really had us focusing on these live discussion sections, the scheduled discussion sections, where the GSIs would be facilitating the students through these questions that are showing up on these homework assignments. And with that, maybe I'll just wrap up and say that this project has also influenced the course design in a different course, an alternate kind of foundational course in statistics and data science, Stat 20. And lots of those lessons are kind of gonna continue on into that course in the fall semester. Wow, right at the
at the second. Thank you.